Welcome to 5.4, Sum and Difference of Sines, featuring Miss Weldon
and Miss Paddock. Okay, today we're on page 9 in your 5.3, 5.6 note packet.
Today's objective, you'll be able to use a sum and difference formulas to evaluate trigonometric
Yes.
Okay, functions, verify identities, and solve trig equations. We'll just go with trig. All right, and now we want you to recall your common Pythagorean triples because that's what we're going to be using today.
Okay, so the first one is the 3, 4, 5.
Then we have 5, 12, 13.
7, 24, 25.
8, 15, 17.
And the last one we want you to know is 9, 40, 41.
All right, so now we're going to recall which quadrants sine and cosine are positive and negative. So in quadrant 1, sine is positive and cosine is also positive.
In quadrant 2, sine is positive and cosine is negative. Cosine.
And in quadrant 3, sine is negative and cosine is also negative.
And in quadrant 4, sine is negative and cosine is positive.
Here are the sum and difference of sines formula you're going to find on the top of page 9 in your notes. And let's go ahead and get started on example 1.
Okay, so on these, what we're trying to do is, if you look, we're looking for a sine of 15. On your unit circle, 15 is not here. So we want to find two angles on our unit circle that either add or subtract to give us 15 degrees.
So we're going to use sine of 45 degrees minus 30 degrees. Now these are not the only angles that will work, but that's just what we're going to use for our example. So 45 degrees is our alpha variable, and 30 degrees is our beta variable, and we're going to be using the difference identity for sines formula. So we have sine of alpha, so sine of 45 degrees, times cosine of beta, so cosine of 30 degrees, minus cosine of 45, sine of 30. You are going to find the values for this on the unit circle. Sine of 45 degrees is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Minus cosine of 45, which is square root of 2 over 2, times sine of 30, which is 1/2. With fractions, we multiply across, so square root of 2 times square root of 3 is square root of 6 over 4, minus square root of 2 over 4. We already have a common denominator, which is perfect.
If you don't get a common denominator, you did something wrong.
Correct, yeah. So we have our common denominator is 4, so 4 is our denominator. Our numerator is going to be square root of 6 minus the square root of 2. There's nothing else to simplify, so that is exactly how we are going to write our answer. All right, example 2.
Okay, here we're looking for two things that add or subtract to 165. So looking on your unit circle, if you use 135 and 30, you'll get 165. So we're going to add 135 plus 30.
So 135 is our alpha. $30 is our beta. All right, so now we have sine of 135.
And we want you to write these formulas out every time you do the problem.
Cosine of 30 plus cosine of 135 sine of 30. We don't expect you to memorize these formulas. They will be given, but you are expected to know how to use them. So sine of 135 we have is square root of 2 over 2 times square root of 3 over 2 plus negative square root of 2 over 2 times 1/2. So we have square root of 6 over 4 plus negative square root of 2 over 4. So we have square root of 6 minus the square root of 2, because a plus negative turns it negative, over 4. And again, that's how we're going to leave our final answer. Okay, our next example is a little bit different. It says find the exact value of sine of alpha plus beta. Okay, they tell you which formula to use, so we're using the sum identity for sine. It says alpha is between pi over 2 and pi, and so pi over 2 is 90 degrees, pi is 180, so our alpha is in quadrant 2. And make sure you draw in your triangle exactly like that. Beta is between 0 and pi over 2, so beta is in quadrant 1, so draw in your triangle.
Okay, so now we look, cosine is alpha, which is negative 3 over 5. Cosine, remember, is adjacent over hypotenuse. So my adjacent is negative 3, my hypotenuse is 5. And then for using your Pythagorean triples, you can find that the opposite side is 4. Okay, on beta, we're looking at 8 and 17. So adjacent is 8, hypotenuse is 17. From your Pythagorean triples, you'll get 15 for your opposite side. So now we can see that the sine of alpha is the opposite over hypotenuse. So that's 4 over 5. And remember, sine is positive in quadrant 2. The sine of beta is opposite 15 over 17. And in quadrant 1, sine is also positive. That's 17, 15 over 17.
Okay, so you want to write down your formula. So you have sine alpha cosine beta plus cosine alpha sine beta. And again, the reason we're using that formula is because that is what number 3 says to use. It says to use the addition one. Sine of alpha we found to be 4 over 5 times cosine beta was given, that was the 8 over 17, plus cosine alpha is negative 3 over 5. Sine beta is 15 over 17.
Okay, when you do this, you should get one of each. The denominators should be different on both of these. Okay, I mean the 5 and the 17, each one should have the denominators. Okay, then you're going to multiply straight across. So 4 times 8 is 32. 5 times 17 is 85. Plus negative 3 times 15 is negative 45 over 85. Again, we got the common denominator, so we're going to just add 32 plus negative 45 is negative 13 over 85. And that is simplified.
Here's a little joke of the day. Math puns are the first sign of madness, which I think that you can all agree that both Miss Patton and I are kind of crazy. All right, number 4, last but not least, it says find the exact value of sine of alpha minus beta. It says that alpha is between pi and 3 pi over 2, so alpha is in quadrant 3. Beta is between, and drawing your triangle exactly like that, beta is between pi over 2 and pi, so it's in quadrant 2. All right, and we have cosine of alpha is negative 5 over 13. So adjacent is going to be negative 5. Hypotenuse is going to be 13. And Miss Padgett, what's the missing Pythagorean triple?
That's going to be 12, but since we're in quadrant 3, it's going to be negative 12.
And then beta, we have opposite side is 15 because it's sine, and a hypotenuse is 17.
Okay, and from our triples, the missing number here is 8. We're in quadrant 2, so that must be negative 8.
All right, so then rewrite your formula. Sine alpha cosine beta minus cosine alpha sine beta.
Okay, so going back up here, let's find the sine of alpha using our triangle. The sine of alpha is negative 12 over the hypotenuse, so negative 12 over 13. And then the cosine of beta is adjacent, that's negative 8 over 17.
And
now
be careful of your positive and negatives because that's going to throw your answer off. So be aware of which quadrant you're in. So sine of alpha is negative 12 over 13. Cosine beta, negative 8 over 17. Minus negative 5 over 13. And 15 over 17. Times 15 over 17. When we multiply that, we get 96 over 221 minus negative 75 over 221.
Okay, if you notice you have minus a minus, so that becomes plus a positive. So 96 plus 75 is 171 over 221, and that is our final answer. Have a great day.